All right, so we got our 8-bit register built with two SN74LS 95Ns. That's the pin out here. And we're using this Octobus transceiver here, SN74LS245N, right? Nah, I don't want to use that for it. Where's pointy? There we go. There's pointy. Right down here. This is the 245, and these are the 4-bit in this configuration, so we can get a total of 8 bits for the upcoming 8-bit bus. All right, so these are the registers. This is basically a buffer that with setting this wire here low, which is the output enable, it will then allow what's in the registers here to go to the eventual bus. This is a configuration inspired by Ben Eater YouTube channel. So here are the registers, and this would be the most significant bit, which would be here, this one, and all the way over here would be the least significant bit, which is here. So currently, what we have programmed is on, off, on, off, on, off, on. We'll get to the output here in a second. And how the output is controlled is by the input here, okay? So it's kind of hard to see, but it's just for principle. So these lit up ones are all set high to the input, which is just tying it to the 5 volts here, okay? So if I change one of these that are low, which is that second one from the right, put it to high. On the next clock pulse, it will change from low to high. So go here, all in one shot. There we go. Okay, and I can keep on advancing the clock, and this still stays the same. So because in this example the inputs are directly tied to voltages and not tied to the eventual bus as well. So that's how you change the input. The output here is tied to the LED, so we can see what's in the registers. Okay, so the buffer here isn't fully hooked up yet, but it's enough for demonstration. Okay, so currently we are on this. We are observing bit number 7 right here, which is this one here. Okay, so currently we are viewing it as a high, okay, because the output is enabled with it tied to low. Okay, so then if we change it, need to find which one it is. It's this one. So then if we change it again back to a low, and we do the pulse, awesome. We are now reading a low. So if we change the output enable from low, which is what it asked for, to a high, okay, let's change it back to a high. And now reconvert it back, we do not get an output. But if I change it back to output enable, then we get our high. And that has been where we are at with the first register. We'll be back.